Hi class, so today we're going to review the memory model a bit before we start our new lesson. So if we're declaring a new object, a new integer object x, and we set that equal to 6, we'll allocate a spot in memory at a certain address and fill in that value with 6, like that. And if we change that value and assign it a new value, say x is 7, what this does is it doesn't create a new object, but rather finds x in memory, and then at that address, the value stored at the address now changes from 6 to 7, as such. Let's say so now when we print out x, we see out x, we get 7. And we can also print out the address of x using the address of operator. So that's just an ampersand x. And what this does is it returns the address of x, which is ox of. And remember, we can also create a reference variable. And so what a reference variable is it's just another name for an object. So if we wanted to create another name, let's say for the object x, object that x stores, we would write int ampersand y is equal to x. And so in memory, this does not create a new object, that's really key. Y is now x, and they're both variable names for the same address and the same value stored at that address. So if we were to change y, so say y is 4, and then print x, so see out x. So we find y in memory, change it to 4, and then we print x, so we find x in memory, and now the value is 4, and that prints a 4. Like that. Yeah.
How do you know when the ampersand is the address of operator or the reference variable?
Okay, so your question was, how do you know if the ampersand is the address of operator or if we're creating a reference variable? So it's actually kind of a simple answer. If the ampersand is coming after a type, then it's a reference variable. And if it isn't, then it's the address of operator. Does that make sense? Okay, cool. So now that we've reviewed, let's move on to new stuff. So the new object we're going to be learning about today in C++ is a pointer. And so a pointer holds an address to another object and points to that object. So let's say we were creating a new pointer called p. The way to declare a pointer is, so if we're declaring a pointer p to x, so it's the type, so the type of the object that we're pointing to, so int, because x is an integer, int star, and then the name of the pointer p. And that's how you declare it. So int star p. And we are going to assign the value. So a pointer holds an address, right? So we wanted to hold the address of x. And the way we would do this is just use the address of operator x. So now in memory, we have a new object called p held at its own address, and it stores the address of x. So this address right here, and now points to x. So if we were to print out p, we would print out p's address, or the x's address, sorry, my bad. We print out x's address because that's the value stored in p. But let's say we wanted to access the value it points to, so this 6, we would use the dereference operator, which is just a star, and then the pointer's name, so star p. And so what this does is it finds p in memory, sees the address it holds, and finds the value held at that address, a 6, and prints out a 6. We can also use the dereference operator to change the value that is stored at the address it holds. So let's say we said dereference P, so star P, is equal to now 5. We find P in memory, see the address it stores, follow the address, and now assign this value to 5. And we print out, if we print out X, we see that X is now 5, no longer 6. Yeah?
How do you know if you're dereferencing an object or declaring a pointer?
Okay, so your question was, how do you know if you're declaring a pointer or dereferencing an object? It's really similar to the reference variable. So if the star comes after a type, that's declaring a pointer or creating a pointer. And if it doesn't, then you're dereferencing the pointer. Does that make sense?
Yes.
Okay, cool. Thank you so much, class, for coming today, and go blue.